All right, so this is lesson 8 of unit 3, and it's using the correlation coefficient. So we'll talk more, remind ourselves what the correlation coefficient is. If you're watching the video, my first or third hour, read this and decide what variables match which scatter plot. So like they're all paired. So for example, daily low temperature compared to boxes of cereal. See which axes should be labeled that, and it tells you like X variable should go on your X axis, Y variable goes on your Y axis. See which one makes the most sense and pair them up together. I'm going to reveal the answer, so you might have to pause. And unfortunately, we discussed this off camera, why each of these answers are the way that they are. But you can see based on the answers, this makes the most sense. So for number 3, it should be A, scatter plot A, because height in feet is directly related to your height in inches. If you have less feet, you're going to have less inches. That has a strong correlation. That's why it's very linear. As one goes up, so does the other. For these other ones, like take the one that would have no correlation. So that would be temperature compared to boxes of cereal. So there's no relationship between the temperature in Colorado and then the number of boxes of cereal in Florida. That's why the graph would look like this. So that's what you should have done in your warm up, is pair them appropriately. Here's the answers. All right, but moving on. So again, today is using the correlation coefficient. So what we are going to do now is take this set of data. We have Priya takes notes for the distance the car drives and the time it takes to get to the destination for many trips. First thing you are going to discuss in your group are distance is one factor that influences the travel time of Priya's car trips. What are some others? And which of these factors, including distance, most likely has the most consistent influence for all of her car trips? So for now, discuss these first two in your groups. Calling you in a second. All right, table 4, give me one factor other than distance that influences travel time. Speed. All right, would you guys agree? Does that affect travel time? Yeah, because if you are speeding, you probably get there faster, even though it might be the same distance. Table 1, what's another factor? Weather. So like in bad weather, you might have to drive slower, maybe your destination less fast. Table 2, what's another factor? Okay, so stops, like if you need to get gas, if you, I don't know, get hungry, I don't know. But when you get to your final destination, that's what we're considering, the number of stops it takes to get there. And then table 3, one more, traffic. All right, if you drive in the middle of the night versus like 3 p.m., probably a lot different in your travel time. All right, so good. Now I'm asking the whole class, which of these factors most likely has the most consistent influence on all her car trips? Even over distance? Oh, I didn't think this is. That's including distance. Oh, maybe I didn't read it, I don't know, but distance does have the most consistent influence, because even say like, for example, traffic, like maybe you hit all the green lights, it'll be a different amount of time than if you hit all the green lights on the way to school than if you hit all the green lights on the way to like fries. All right, maybe that has the most consistent influence, even though there's other things that can fall into play. So that's why if I were to show you this scatter plot, you might not see that it's like a perfectly straight line because we have all these other factors that play into it that might, you know, make it take longer or slower. So what you're gonna do now is use technology to create a scatter plot of the data and add the line of best fit to the graph. We've done that before, so practice it again, every single person. If your Chromebook's not working, use your phone. You need to be able to plug things into Desmo. So you're using this data, making a scatter plot, putting the line of best fit on it, and then write down your equation that you get from your best fit line. I give you 2 minutes to get that. And then if you finish early, then answer the rest of the question. But I need your equation for the best fit line in 2 minutes. Yes. Okay, so teach me as if I had never done this before. How do I get the answer to number 3? You have to insert a table. How do I do that? Okay, great. What data am I putting in? So from the table that you were given in your notes, I'm looking for it right now myself. All right, and then you just copy it exactly how you see it. So if you leave off any points, it could make a big difference or it could not, but you definitely don't want to like skip any. Remember that during the test, I will not help you with this. Just like your state testing, I can't help you with your calculator. Oops, I messed up. So I added in my table. Now what? How do I get the equation for my line of fit? Okay, so what exactly do I type? Someone other than Justina, please. So this squiggly line that's on your keyboard, it does look like an approximation symbol. All right, but the equation is what you're supposed to get from this for number 3. So we inserted the line. How do I read this to tell me what my equation should be for the best fit line? Y equals, what do you think I should round to? All right, what's my equation? Did you say 9.3 or 9.2? Okay, good. Yeah, just making sure we rounded right. So let me finish copying that down. But yeah, make sure you guys know your rounding rules. Whatever you round to, keep it consistent. Sometimes it specifies like round to a certain place. And this one, it didn't. So just make sure you keep it consistent, whatever you do end up rounding to. But again, just to review your rounding rules, if I decide I want to round to 2 spots, wherever you need to round to, look to the right of it. Since that number is 5 through 9, you round up 1. Then for my y-intercept, whatever you choose to round to, keep it consistent. If I want 2 decimal spots, underline that second decimal spot, look to the right. Again, that number is 5 through 9, so we round up 1. So I have my linear model. Next question is to tell me what the slope and y-intercept mean in this situation. So 0.93 what? 4.15 what? What do those mean? Additionally, we are going to, in that same Desmos that we already have up with all the info, we're gonna identify the correlation coefficient. So once you've answered 4, see if you can identify the correlation coefficient. So it's not just enough to be able to identify it, and you can use technology to identify your slope and y-intercept, but on your test, you will also have to interpret it in whatever situation is going on. So whatever two things are being compared right now, it's distance to time spent in the car, I guess you could say. We're comparing those two things, and this model is what we generated for that. What is my slope representing in this situation? So slope, which is 0.93, represents what, Riley? What is my x in this situation? So hold on, let's kind of talk everyone through it. What's my x in this situation? Distance in miles, and then what's my y? Ordinarily, I prefer that the time be on the x-axis, but it's whatever depends on what. Okay, so it looks like the minutes spent in the car depends on how many miles are driven. All right, so that's a clean graph. So remember, slope is rise over run. So technically, my slope is 0.93 over 1. So see what the y is, when rise would be your y-axis, and then run would be your x-axis. So it's 0.93 over 1. So what does that mean in the situation, Riley? Every 1 minute, 2 minutes, 0.1. Close. Oh. Correct. So for every 0.93 minutes, she traveled 1 mile. All right, that's how I think you can best make sense of each thing, because what's on your x-axis, miles, what's on your y-axis, minutes. Slope is always rise over run. Slope is always rate of change. So it's what it's changing by for every like increment of 1. So that's how you can think of it. 0.93 minutes. She traveled 1 mile. For every 0.93 minutes, she traveled 1 mile. Questions on that? All right, now my y-intercept. Let's take a look at our graph and see what our y-intercept even is, so that we can interpret it. So my y-intercept which is what value according to this? What's my y-intercept? Okay, good. So same from our equation, but also nice visual reminding you y-intercepts the y-axis. 4.15 what exactly? So 4.15 minutes. I agree, because minutes is on the y-axis. And here's how we should probably phrase it. So that's 4.15 minutes has gone by when she travels how many miles at the y-intercept? So go back to your y-axis. At the y-intercept, what's the value of that? Yeah. So, and remember, x was distant. So that's how much time she spends traveling, even when it's 0 miles. 4.15 minutes when she travels 0 miles. So y-intercept is always your starting amount. Or in other words, whenever x is 0, that's going to be your y-intercept, because at the y-axis, all the x's are 0. So here's how the book phrases what we just talked about, but it should be the same. I do think we did it the right way. So the slope represents the number of minutes it takes to drive 1 additional mile using the linear model. Assuming the linear relationship continues, the y-intercept represents the number of minutes it takes to drive 0 miles. This may account for things like time getting ready or warming up the car before driving. So does that make sense? Okay, and we did phrase it the right way, but now it might make more sense why she's traveling 0 miles, but still 4 miles or 4 minutes have gone by. All right, now the last part of this, correlation coefficient. This will make more sense for you guys tomorrow when you get to that lesson. But did anyone identify the correlation coefficient with their technology? Yeah. What did you say, Jude? All right, so let's see where they got that. It kind of gave you a hint. It said R equals what? So let's go back to our notes. In this little menu of stuff, I told you we would eventually use all of it, except for the R squared. We're not going to use the R squared in this level of math. But look, it says R equals, and then if you round it, 0.99 would be correct round. So that is correct. So you already knew how to do all the steps leading up to this. Now you just need to be able to look at that little area, your statistics, and identify R as your correlation coefficient. I know it doesn't really sound like it should be an R. Don't confuse it with residuals, but that's what we call it. So that's my correlation coefficient. If I wanted to find it using technology, I just put it in my table, type this in, and it gives it to me. Questions on that? Now from lesson 7, you'll get what that means about the data. So in lesson 7, you will learn that correlation coefficient goes from -1 to +1. And that the farther it is from 0, so farther from 0 equals like a stronger linear relationship. So 0.99, and know that we're going from -1 to +1 when we talk about R values. It will not go outside of those values. In between, yes. But would you say that 0.99 is pretty far from 0? Yeah, if we're just going from -1 to +1, 0.99 is almost the farthest from 0 that you could be. It's like really close to the 1. So would you say that this linear relationship is strong or weak? Mm-hmm. All right, raise your hand if you think strong. Raise your hand if you think weak. Raise your hand if you have no clue this linear. Okay, so let me tell you again. And this will make more sense for you guys, period 5, tomorrow when you do lesson 7, because you guys will do that tomorrow. But I'm telling you now, I'm giving you some information. R values, correlation coefficient, go from -1 to +1. So what are some numbers in between -1 and +1? 0. What other numbers are between those numbers? 0.5, 0.1. There's lots of numbers in between those numbers. So in that case, I'm also telling you that the farther that number is from 0, and remember our limits are -1 and +1. The farther from 0, the stronger the relationship is between those variables. It gives it like a measurement. So not just me telling you, yeah, your travel time is affected by distance. It's me showing you with the value, this is how strong that relationship is. So if it's 0.99, do you think that relationship is strong or weak? Strong. So how would you describe it? You would say that it is strong. And would you say that this R value is positive or negative? So then it has a strong positive relationship. So whether it's positive or negative will be the sign of the R value. The farther it is away from 0, the more linear your data is, the more of a straight line your data is. Does that make sense? Okay, well, we still have some more time to learn it, so I have faith in you. When you are asked to describe correlation, make sure you tell me whether it's strong or weak, and whether it's positive or negative. Those are the 2 things we need to do. All right, so then on to the next thing. We have something called correlation due. For each situation, you're going to describe the relationship between the variables based on the R value, based on the correlation coefficient. So make sure you mention whether it's strong or weak, and whether it's positive or negative, based on these R values. Questions on what you're doing. Okay, it's 6 things, so I think we'll go over it in 6 minutes. When and if you finish early, then move on to the practice. All right, but only after you answer this, because we'll assign a reporter, and we only have 4 tables, there's 6 up there. So some of you may speak during this, and it's been a while. You need to tell me for each situation, based on the correlation coefficient, the R, whether it's strong or weak, and whether it's positive or negative. Strong, and then you have to mention whether it's positive or negative. Positive. You guys agree?
Yeah.
Okay, good. It's pretty close to 1. And remember, our values go from -1 to +1, so pretend like this is a number line. The closer that it is to 0, the weaker that it is. So weakest at the 0, but then strongest at the +1 or the -1. Okay, the sign itself just tells you if it's positive or negative, the R value. All right, so then now whoever spoke for your group last, go 1 to the right. Whoever spoke for your group, the more recent time, go 1 to the right. So table 3, when the R value is 0.84, how would you describe that relationship? Strong and positive. All right, class, you guys agree?
Yeah.
Okay, I would agree. 0.84 is still pretty close to 1. Is it closer than 0.92?
No.
Okay, so maybe at the end we'll rank them like strongest to least strongest, but yeah, strong positive is how I'd probably describe that too. So then table 4. When it's -0.86, how would you describe that?
Strong negative.
Strong negative. So still farther from the 0, closer to the -1 than to the 0, so that's why it's strong. Negative, because there's a negative sign. Make sense? Okay. Table 1, when it's 0.73, how would you describe that? Strong positive. I would also agree, we'll rank them at the end, so you can kind of see like, which is the strongest, which is the weakest, but still closer to 1 than say 0. So I would still probably classify that as strong. Table 2, what about when it's 0.28? What is it? A weak positive. So here's our first weak example. I would say probably anything other 0.5, personally for me, I'd classify as weak. Whether -0.5 or positive 0.5, closer to 0, the weaker it is. And positive, because it's a positive number. All right, table 3, last one. When it's -0.17 for the R value, how would you describe that correlation? Okay, good. Now for these, we mostly just had to look at the R value. You can look at the variables that they represent and see a pattern there. But R values are the main ones. Out of all the R values here, which was the strongest? Okay, so let's rank them from strongest to weakest. 0.92 is the most strong. What's the next most strong? -0.86. That one is the second strongest. What's the third strongest? 0.84, the third strongest. The fourth strongest. And then my least strongest is this. So as you can see, the strongest doesn't depend on the sign, it depends on how far from 0 it is, from -1 to +1. Good, any questions? Okay, make sure you do your practice. You'll have time tomorrow, for sure.